Hello, guys. How are you all? Uh, I'm Pragadipta, and welcome to the session 6 of Robotics Workshop powered by Savishkar CUK. All right, guys. So, as we have came this far, where we have understood, starting from Pictoblox, we have reached to how to code in IDE. And in today's session, we will be learning how to interface sensors with our Arduino, right? So the sensors which we're going to talk about in today's sessions are our uh, ultrasonic sensor and LDR sensor. All right. So let's move into our session where we will be exploring how the sensors look like, how they works, and everything. All right. Okay, so what's our objective? Our first objective is to understand how the digital signal, analog signal works with Arduino processors in order to interface our sensors, right? And then we will be learning how the hardware and how to do the codes for interfacing a HC-SR04 ultrasonic sensor. So this is the actual name of it, which is HC-SR04 ultrasonic sensor and the light dependent resistance, which is LDR. Amazing. So let's forward into the session. Yeah. So as we know that we have two types of signal. One is digital, one is analog. So digital signal are discrete signal, which has two states, high and low. Right. On the other hand, analog signal is a continuous signal. Okay. So if you plot it in a graph, so the graph will be like it will be continuous with respect to x, y axis. Okay. So uh, if we talk about ultrasonic sensor, so in order to interface a ultrasonic sensor, we use the digital pins because it gives us a digital signal where it has two states. Okay, either it's high, okay, or 5 volt, or you can say when it's on, or either it has a low, off, or zero voltage, right? So it uses basically a discrete event like button pressing or timing pulses, and it has four pins in an analog. Like if you talk about ultrasonic sensor, it has four pins. We will see those four pins, and there it generates pulse of signal which has high, low range of signals, right? And then if we talk about analog signal, then the LDR sensor which we are having for the light dependent resistance, that's is used to measure the varying intensity of light, all right, or temperature you can say. So just understanding the value of light, the change of light, it gives you the output, right? So before we move on, uh, yeah. So yeah, here we are having ultrasonic sensor. So before we going into working with it, before we start writing with the codes, let us talk about the ultrasonic sensor. So ultrasonic sensor is used to measure distance between two objects, right? With the help of sound wave. Okay. So you have probably heard about uh, sonar, which is used by the safe navigation and uh, defense purposes, right? So on that case, what happens is it emits a sound wave, and that sound waves when bounce back from the object, it can detect the distance between the object and the sensor by calculating the speed of sound and the time taken to travel the sound wave back to the sensor, right? So, if we see here, you can see in this picture of the sensor, we are having four pins in the sensor. So, one is VCC, or it requires 5 volt. This is ground, or you can say this is GND. Okay, so this is the ground which we are having. And here we are having two pins. One is the trigger pin, and this trigger pins is basically what generates and emits the sound burst. Okay, or we call it as ping. Okay, so it generates the sound burst and it emits the sound burst into the air, and then we are having this echo pin. All right. Now, what this echo pin does? This echo pins basically it's like an ear you can see, which can hears or it listens the return signal. All right, and another parameter which we calculate using this echo pin and trigger pin by just taking the time difference of emission of a wave, sound wave, and the receive when the time when it receives the sound wave, and we call it the duration. Okay, so it's the time taken for the round trip, the time taken to emit and then uh, bounce back from the object and return to the sensor, right? And calculate the distance. What we require is we require this formula. Okay, so in this formula you can see that if you want to find the distance, the formula is duration multiply by 0.0343 divided by 2. Okay, so this thing you have to remember in order to work with ultrasonic sensor whenever you want to calculate the distance between an object and the sensor, you must use this formula in order to calculate the distance. And this distance will be in centimeters. Okay, so this distance will be in centimeter. Got it? So this is about our ultrasonic sensor. Now let's talk about how to interface it with Arduino. All right. So as we have discussed, it has four pin, right? So what are those four pin? So one is VCC. So you have to connect the VCC with the 5 volt. You have to connect the ground, okay, with the ground pin of the Arduino, and you can then take any of the digital pin, right? So you can take digital pin 9, digital pin 10, digital pin 3, 5, whichever you want, right? So that way one will be for generating the sound wave and one will be to collect that sound wave. Okay, so you have to always double check this, that the VCC and the ground is in the right place. Okay, prevent the short circuit in your circuit whenever you are interfacing ultrasonic sensor. All right. Okay, guys. Now let's code for our ultrasonic sensor. Right. So before we code, let's talk about the logic which we're going to follow. Right. So let's talk about the logic flow which we will be taking care whenever we are interfacing ultrasonic sensor with our Arduino. So the first thing is trigger. So whenever you will be interfacing the ultrasonic sensor, the first thing you should consider is to generate the pulses or the sound waves, right? For that reason, you have to send a 10 microsecond high pulse, or for 10 microsecond, you will give a signal of high, right? And then low. All right. So that way you can generate a pulse. Next thing, what you have to do is you have to just use pulse ln function to measure the echo pin duration. Okay, so in order to measure the echo pin duration, we have to use the pulse ln function. Then we have to calculate uh, the distance by using the sound of the sound speed formula, which we have seen just in the previous slide, right? So this formula we have to use, and then we have to calculate the distance between the sensor and the object. All right. So now, as we understood the logic uh, connections, let's move into the actual coding part. So yeah, right now I'm in IDE. Okay. So yeah, I'm in IDE. I think you can see. So now if I talk about ID, yeah, yep, I think you can see right now. So this is my ID code. First, as we have learned in our previous session, what you have learned is code anything in ID. The first thing we do is define pins. Okay. So to define the pins, as we see that in our ultrasonic sensor, we require four pins, right? And out of four pins, we will be using two pins, which is trigger pin and echo pin, as our variable, right? So first we have to define the variable in order to work with it. And the first variable which we will be working with is the trigger pin. So let's define it. So let's type it constant as all the pins are integer value. So integer. And let's name our variable as trigger pin, trigger underscore pin. All right. And let's say it's equals to whichever pin we want to take, right? So I will be taking pin number three, right? And then define constant integer, the echo pin, right? So echo underscore pin. So we have defined our echo pin, we have defined our trigger pin. Let's take the pin number five for it. Pin number five. Okay, so it's about defining the variables. So we have successfully defined all the variables. Now we will be learning one another thing. For example, in order to understand, we will be taking the input, we will be knowing our sensor, we will be knowing how much distance far away our object is, right? But we need to see, right? We need to visualize it. How much, distance far away the object is from the sensor. We need to see, right? So for that case, we will be using one function called serial output, right? So it will show us the value. Okay, it's basically just like a place where you can see, uh, or where it can print our, this Arduino can print like the distance, right? So we will be using it. So in the void setup, first you have to set up this. So for that reason, we will first start with the serial code for that. So we will write serial beginning, right? Beginning. Then you have to set it into 9600. Okay. Next, what you have to set up the pin modes, right? So let's set up the pin modes. Pin mode. Now, as we have discussed, right? So our trigger pin, if I want to show you, so as you can see in our trigger pin, what we are having, yes. So this is our ultrasonic sensor. As you can see, we have explained that our trigger pin is basically sends the sound burst or the ping, right? So for that reason, what we have to do is we have to set it as output, right? Because it's generating the sound wave or the sound burst. So that's why we will take it as the output pin. And the echo pin, we will take it as the input pin because it will listen the sound wave which is coming towards us, right? So it will be our input, right? So we will be um we will be taking respectively, right? So let's define it. So the pin mode, we have to define the trigger pin as our output, right? And then we have the pin mode, and we have to define echo pin as input, right? That's it. That's all about the set. Okay. Now, now let's talk about what's next. So now let's talk about what will be under the loop, right? So in the loop, what we have to do, as per the logic, we have to first send the trigger pulses, right? So I will take the comment and I will write first, you know, um, let's say send the trigger pulses. So for that reason, what we have to do, we have to give the trigger pulse for 10 microsecond, right? So for sending the trigger pin, so turning the trigger pin for 10 microsecond, we will be generating the uh, pulse of signal. So what I have to do, I have to write digital write in order to give the output. So I have trigger pin, right? I have trigger pin, this is my trigger pin, right? And I have to put it for say uh, first low. Okay, we need it to set at low. Then I will use another function as you know about the delay function, right? So it delays you for, if you write it 1000, it will delay for uh 1 second, right? But if we want in microsecond, what we have to do is we have to write this function, which is called delay in microseconds. Right? Yeah, it's seconds. So this will delay it by microsecond. Okay. So what we have to do is we have to delay it for microsecond when it's low for 2 microsecond. And when I am putting it on high, right? Right. I'm having eco pin, open into high. Okay. Now delay, right? It will be for 10 seconds. So we have seen in the PPT, right? So we have to set it to, you know, high whenever we have to set it for high for 10 microsecond in order to generate the pulse. Okay. So once it's high, then we have to make it low. So I will say digital, right? Trigger pin. Oh, I'm so sorry. I'm so sorry. We have to take the trigger pin only, right? Trigger pin. Yeah. So we have to set the trigger pin first to low, right? For 2 microsecond. Then it will be high for 10 microsecond, and then again it will be low, right? So that how we can generate the pulses, right? So I will do trigger pin and I will set it at low. All right. Amazing. Now what is the second thing? So once we have generated our signal, what the next? So as per our logic, what we have to do is we have to now measure the echo duration. Now we have to measure the duration. For that reason, we will be using this function long, this data type which says long duration, right? And we will use our function pulse ln, pulse, pulse ln, right? Inside it, we have to write echo pin, echo underscore pin, and we have to set it high. So using this function, we can collect the received sound wave, and it will be it's basically checks the sending sound wave and the receiving sound wave time, and then it differentiate between them, and then it can understand what is the duration of the time taken for the sound wave to travel back from the object. Okay. So this is the function. No need to worry about it much, as you just need to use these functions in order to work with the sensor. So I'm not going deeper into the concepts that gonna make you more confused. All right. So this is the function which we use, and this is how we can measure the echo duration time. Right. Then what is the next part? Our next part now is to calculate the distance. Now, in order to calculate the distance, uh, what we have to do? So basically, we all know that the speed of sound is around 343 meter per second. So in order to calculate it, what we have to do is we have to just multiply the duration into the sounds of speed of sound, and we have to divide it by 2. That's the formula says, right? So for that reason, what we need to do is first we have to declare the distance, as we haven't declared it here. So what I will do is we will declare it float variable, FLO, float variable. And this float variable is distance, and let's by default set it to 0. Right. So this is our distance. Now we require this distance variable. Now what I will do is I will just take distance equals to bracket duration multiply by our speed of sound, that is 0.04, sorry, 34, right? 343. Okay. And now let's divide it by 2. All right. Amazing. So this is how we can calculate the distance. Now, whatever distance we are calculating, that will be saved into this variable. But I want to check the value of this variable. And for that reason, we will be using serial monitor. And see, you can see here, there is something called serial monitor where you can monitor the output of any of the variable, right? So for that reason, we have to use the serial monitor. And using the serial monitor, we have to first define this serial dot begin 9600. Right? So now let's see the output, right? So output, uh, you know, to serial monitor, right? So for that reason, what we need to do is we have to write simple serial dot print. Okay. And now let's print the distance, right? Okay. And semicolon. So what it will do, it will print distance, and then it will give a space. And in that space, I have to write serial dot print the variable distance. Okay. So whatever inside this code, okay, that's a double quote, it will be a string, right? Or just a normal letter, whichever you want to print. And then this will be the distance, okay? And that distance will be basically in centimeter, right? So I will again like serial dot print ln. So serial dot print ln, and it will be in centimeter, right? I will tell you what is the difference between serial.print and serial.println. Okay, no need to worry about it. So then we need that we will give a delay of, see, 5 millisecond. Okay, so 0.5 second delay we will be using for every reading. For example, for every 0.5 second, it will be checking the distance between the object and the trigger pin. All right. So this is all about our code. Now let's move into our next part, that is about the connections, right? So let me show you. All right. So as now you can see, so as you can see, this is my Arduino, right? Okay, let's make it bigger, right? So this is my ultrasonic sensor, right? So in this ultrasonic sensor, I'm having my four pins, right? You can see. So if I want to show you, yeah. So you can see I'm having four pins, right? So this is my VCC, right? This is my ground, and this one is trigger pin and echo pin, right? You can see whatever pins are written here. So you have to just connect it with some jumper wires, which is a female to male jumper wires, and I have connected it like this, right? Now I have to connect it with the Arduino Uno, where I will take the VCC and I will connect it to the 5-volt output. Then I will take the ground pin and I will join it to the ground. It's done, right? Next, what we have to do is we have to take the trigger pin and our echo pin. So, as in the our code, what we have taken in our code, we have taken the trigger pin as 3 and echo pin as 5, right? So this is our trigger pin, yellow one, and we will go for the pin number 3, right? And we will go the echo pin to the pin number 5, right? So this is all about our connections. So we have connected the VCC ground and the trigger pin and the echo pin respectively. Right. Now let us talk about our next part, right? So the next thing which we're gonna do is basically we want to upload our code. For that reason, what we need to do is we have to just connect this USB to our USB port, right? All right. Yeah. Let me just connect it. So I have connected my Arduino with the USB port. Now I'm gonna show you how it's gonna look like, right? So side by side, I will show you how it's looks like. All right, and just a moment. Okay, so this is my yeah. So now see, this is my side by side view of the compiler, right? So this is my compiler. You can see here IDE, and this is my uh, Arduino. So it's a best of view. Now what I will do is I will just first thing I need to do is select the board. So I will go to this and you can find this COM4 serial port USB, right? And then you have to select Arduino Uno, right? Now click on OK, right? So as you can see, now we will be uploading the code. So what you have to do is first compile it. Good to give semicolon. Okay. This is delay. This is delay microseconds. Right. So in the hardware part, when you directly code with C++, this type of mistakes happens, right? So it's happening to me, and it will happen to you also when you will be coding without the help of any chat GPT or anything. Right? So let's just compile it. Compilation done. That means our code is correct. Okay, just make sure this is pulse N, it's not pulse LN, right? So let's try to upload it. Yeah, done uploading. So our code is uploaded, and this is our hardware, right? Now what we have to do is we have to see the distance output. So we have to go to the serial output. From first we have to go to the tools, then we have to select the serial monitor. Once we select our serial monitor, we can see it's calculating distance, right? Saying 4 centimeter. Can you see? When I'm increasing the distance, increasing the distance between me and this, this object, right? So whenever I'm moving the object far away, distance increases. And when I'm making, like when it's coming close to it, it shows less distance, 3 centimeter. Once I increase it, it shows 9 centimeter, right? And every zero point 0.5 seconds, it's check it. All right. So yes, that's how we can, integrate ultrasonic sensors in our circuit. So we can do various operations like object detecting robot, right? So that's how we can work with our ultrasonic sensor. All right, guys. So we have done with ultrasonic sensor. We have learned how to integrate ultrasonic sensor with our Arduino Uno. Now let's talk about LDR or light dependent resistance. What is LDR? So it is basically a photoresistor and it works in the principle of photoresistor where its electrical resistance changes based on light intensity. So, how much light is falling into the sensor, as per that, it changes the resistance. So, the brighter the light, the lower the resistance, okay, or the electricity will flow easily, okay. But the darker it is, uh, the higher the resistance becomes, or less electricity can flow into this resistance. And this is how it looks like, the LDR looks like, right? So as you can see, it has two terminal, right? And it's nothing to deal with positive or negative. You can use any of this, okay? So the resistance are series in nature. So the thing is, the Arduino can measure voltage, not resistance. Okay, so it is a very important thing to note that Arduino can only measure the voltage. It cannot measure the resistance. So we need a voltage divider circuit. How it's look like? So probably you have heard about it in your 11, 12. So a voltage divider circuit looks like this. Okay. So we will be setting up our LDR in our circuit just like this. What we need to do is we have to first take the VCC and the negative terminal or ground common into our breadboard. Then we have to connect one end of the LDR with the positive voltage, right, and another with a resistance of 10 kilo ohm, right? So this is a 10 kilo ohm resistance, and we have to connect other end to the 10 kilo ohm resistance, and we have to connect it with the ground pin, right? So we have to connect it with the ground pin, all right? So that's how we have to connect it. Then we have to take the analog input from this end where this resistance end is ending, right? So we have to take jumper wire, and then we have to connect it with any of the analog pin you want. So we will take the analog pin A0 for that. All right, so this is about the connection. Let's first do the connections so it will be much clear for you how to do the connections, right? So let's do the connection first. All right. So let me expand it more for you. Okay. So now we are having our breadboard. So this is our breadboard, right? So this is our breadboard. We will take this part of the breadboard. This is our Arduino. Now I have to just put the, LDR, any of the two holes, right? This is our LDR. Then I have to take um, VCC from my Arduino Uno, So I'm taking VCC. I have to connect it to any of its terminal, say here, right? So I've connected here. Now I have to first connect any of the end with the ground, right? So let's take the ground and let's connect it uh, to the common ground first, right? Right. Then I will take my resistance, 10 kilo ohm resistance, and then I will take it from the ground, right? And I will connect it here, right? This is how we can connect the LDR. Then I will take another pin and I will put it in between the resistance and the LDR, right? So I will take this and then I will connect it to the analog pin A0. All right. So this is the connection which we have done, what we have seen, right? Now, what I need to do is let's talk about code, right? So let's talk about the code and yeah. So we are into our IDE. Okay. So now we will be coding our you know, right. So let's code, guys. Okay. So let's for the code. First, we need to remove previous code. Let's remove it. And now let's write our code, right? So for writing our code for LDR, the first thing is we have to define the pins, right? So first pin is constant, say LDR, right? Which is equals to, let's take the pin A0, right? Capital A0, right? Now, now what we need to do, we have to set the void setup, right? So let's void setup. Inside that, we again need serial output, right? Serial print. So we will define serial begin and it will be 9600, right? Then we have to define the pin mode and our pin mode is LDR. We can write it LDR pin. It's your choice. Let it be input, right? And now we are done with our void setup. Now, once our setup is done, we have to write a void loop, right? Inside our void loop, the first thing we need to do is we first have to read the analog value. And what is that analog value? Our analog value is having the range of 0 to 1023. Okay. So this is the range, right? So for reading it, what we need to do is we need a variable int, say this variable as LDR value, right? Let initialize it with 0, right? Let the value be 0 first. Right. So now we are having the variable LDR value. So I will just write LDR value, LDR, value is equals to analog read. So whenever we are working with analog signal, we need to use this function analog read. So digital read is there, right? So this is analog read, and this will LDR, right? So this will read the value or the voltage which we are getting from our resistors, right? So what is the voltage difference we are getting in order to whenever we are giving less amount of light, more light intensity. So this is our LDR value which will be collecting the analog readings, right? Now, what we have to do is we have to convert this value will be 0 to 1023, right? So now we have to change it into say percentage. We want to see how much percentage of light it's getting, right? So for that reason, um, let's take another variable which will be be the percentage of it. So let's define it as int light percentage, like percentage, right? Let initialize it to 0. Okay. So let's copy this. Right. Now, what I need to do is I have to now convert it to percentage, right? So for converting into the percentage, I am having my light percentage variable, and I will just use the map function we have talked about the last session. So we are having LDR value, right? And for the LDR value, I want to change it from 0 to 1023, which we are having, to 0 to 100. Right? So in percentage, we are having 0 to 100%, right? So we'll map it to 0, 1023 to 0 to 100. Okay. Then the next part is to see our output, right? So output, to see our output, what we have to write is first serial, right? Print, let's say serial print our LDR, sorry. So we will be seeing the LDR raw value from 0 to 1023 and also the percentage, both, right? So let's see the raw value. Okay. So this is just a text. Now serial dot print, okay, serial dot print and the LDR value variable, right? Right. So this is my LDR value, capital V, right? So this is my LDR value. So it will print the raw, fan. All right. Next, what we have to do is, yeah, done, right? So next is our light percentage, right? Light percentage. That was the raw value. Now we will be seeing the percentage, and that is, in our this variable light percentage, right? So it will print that, and we will end the serial port by writing serial ln, which means it will end it. So at the end of the serial print, we have to always write serial ln. So it will be in percent. So it will be in percentage. It will show the light intensity in percentage, right? And we will check it after every, uh, 0.5 seconds. So it will be 500, right? Okay, guys, we are done with our code. Let's just upload it. As you can see, we need to, yeah. So you can see the hardwares, right? Now let's just run this code. And to run this code, we have to first compile it. Yeah, so it's a constant integer. Now just as we are done with our code, just compile it. So our code is correct. It's compiled. Now let's just upload it. All right. So we have to just disconnect and connect it again. Let's compile it. Yeah. So we have uploaded our code. To see our output, we have to go to serial monitor and we can see it, right? So right now the light intensity is 100% it's showing, but or you can say it's getting around 4%, but if I cover it, it's getting 0, but it's now 100%. If cover it, it decreases the value, right? It's getting 0% of, or around 4 to 5% of the light when I'm covering the LDR. But the moment I'm removing it, it's getting 100% of the light, right? All right, so you can see the it's getting 100% of light when it's not covered, right? You can see the raw value and the percentage. Now, the moment I cover it, you can say the light decreases, right? So it says 1% of light because I have covered the LDR and it's not getting the light. And the moment I remove my hand, it's getting 100% of light. So, and this, the way, it's get covered, it's get 1%, 0%, right? So it will be depending on the light which is getting, will show you the output. So this is about how we can interface LDR, and this is how we have came to the end of our session 2, right? So here we are at the end of our session, and if we go to next, so this is about the analog input, how we have calculated as we have discussed. All right, guys. Now, I'm going to give you a challenge. If you can give it, it will be really great for you. You can define as a project. So, your project will be to use the LDR to detect if it's a nighttime, like if it's a dark, uh, or it is a daytime, right? So, and activate the ultrasonic sensor to scans the intruder, right? So that way you can do. Although in the like your assessment, I will write the exact problem statement, and you can try to build it by your own. You can work with the simulation Wokwi, and you can build your own smart security system. So that's all for today, guys. Thank you so much for watching the session. See you in the next class and the last week of our session. Goodbye.